Hello, students, YouTube learners. This is Dr. Satish Singhal, PhD, Professor of Computer Science, El Camino College, Torrance, California. I'm here in design example 5, data processing using nested loop, video 204. This part's focuses on analysis. So this is probably the most important video of the 4 videos. If we don't understand analysis, then it would be impossible for us to understand pretty much anything, algorithm or source code or anything else. Okay, so let's focus on this one. We're going to describe some of the videos, some of the PowerPoints that we saw in video number 7. So this you saw before. What is the structure of the file? Before you can process a file, it's very important to understand its structure. So we have student test score records, and there will be variable number of tokens in that. So we are seeing 3 records here. All records have first last name, first last name, first last name. Okay, and then there are variable number of test scores. Here we have 4, here we have 5, here we have none. So students need not have taken same number of tests. And each record ends with a sentinel impossible value for the test score. Obviously, at El Camino, we don't give negative points in the test, so that becomes a sentinel value. Okay, so we saw that in video 7, and we are reviewing this. That's the file structure. In order to make this slide, I've left spaces, but in real file there will be no spaces. One record, second record, they'll be continuous without any white space. Okay, second part. So this was file structure description. The file programs cannot be done. File reading programs cannot be done without fully understanding the file structure and what the parsing technology would be. So here I'm describing the file structure, which I've described in previous video also. But take that as a general principle. You cannot parse a file or read a file unless file structure is analyzed and understood. You cannot read a database table unless table structure is analyzed and understood. What is the meaning of that analysis? It's called metadata. What is the metadata here? Metadata here is that each record must have 2 names, first and last name. That's one of the metadata. Second metadata is that each score ends with a sentinel value. That's the second metadata. And third metadata is that there could be any number of scores or no scores, only a sentinel value. So anytime you look at a file which you want to process, investigate and see what its metadata is. What is constant among all the records? That would be its metadata. Okay, you'll learn a lot more about metadata when you do a database class. All right, but it starts to appear just about everywhere. Let's look at the second second slide. So second slide is that how are we processing students who took one or more tests. So we have a record here, John Doe, first and last name, took 4 tests. First test scored 90, second 80, third 85, fourth 87, and that's the sentinel value. So the structure of the program will be our outer loop will be an EOF loop. So this line, some code line will read first and last name. So out of this whole record, we have taken out this much in this line. And then its program is going to read the first score, which would be 90 in this case. That's called a prime read. It's stored into a variable called oneScore. And once again, we are designing a sentinel loop here. Sentinel loop must have a prime read. If there is no prime read, I don't care what you call it. It's not a sentinel loop. And if any software asks, actually test, in real life you can do whatever you want to do. If any test asks you to write a sentinel loop and it doesn't have prime read, then you have not done the prime sentinel loop, and that means you have no points for the sentinel loop part of the design. So understand this very well. I have students actually drop the class because they didn't want to do this. They didn't want to do the prime read. They were just totally stubborn about that. And I kept telling them, well, you could do a loop 50 different ways, but I can't call them sentinel loop. Sentinel loop has to have prime read. And if you don't do that, you have not designed a sentinel loop. Prime read. So prime read will read 90 for the student who took one or more tests. Could even be 0. Doesn't have to be 90. Could be 0. But then this condition will be true. One score greater than or equal to 0 will be true for 0 or anything above 0. That means we're going to be entering the loop. And there we have variable sum. Into sum we add the sum one score. Sum will be initialized somewhere here. So that way we are adding the score of the first test into the sum. Sum will be set to 0 here. And then we need to count how many tests there are because we need to take an average later. That will be sum divided by num test. So I read 1, I summed it up, so I'll increase num test variable by 1. And then I'll read next score or sentinel value depending upon how many values there are. And next time in the first loop iteration I'll read 80. 80 greater than or equal to 0 is true. So then I add 80 to the sum, increase that by 1, which will become 2. And then I'll read in the second loop iteration 85, which is greater than 0. So this executes again. Then I'll read 87 in the third loop iteration. And that get added here. And this will increase again by 1. After that, finally, I'll read -1, which is the sentinel value. And -1 greater than 0 is false. So I'll exit the loop. And I will then, I have the sum and num test. I'll find their real average, rounded average, and use the grading criteria, a greater than or equal to 90, all that I've described in video 1. And of course, you have that in this document in your earlier pages. So that's how we process a student who has taken one or more tests. All right. Then there'll be a student who took no test, like Miss Genius. We showed that earlier. So their situation will be something like this. There's first and last name and a sentinel value. So outside the sentinel loop, but inside EOF loop, you're going to be reading first and last name. So those two tokens are consumed. But then in reading first score, -5 will be stored into the one score variable. One score greater than or equal to 0, -5 greater than or equal to 0 is false. And then loop will not even be entered. That's the characteristic of pretest loops. Sometime, depending upon the type of record, they may not execute at all. And since sum was 0 and num test was 0 set here somewhere, those are accumulators. We will find out that no tests were taken, and then somewhere we'll do if and else, and we'll print message that no tests were taken. And then depending upon how many records we are processing, this condition will become false when EOF character is read. That's described in great depth in video 7. So please revisit that video again. And of course, my ebook describes that too. So those are the situations we are going to encounter in the software. And obviously here you can see that there's this one loop, there's second loop, and then before that we are opening files and validating the file, opening conditions. Those control structures are there, and then there will be control structure for determining the grade. So we have to see those control structures in totality to see what the software structure would be. And there is a flow chart. Maybe I can visit that now rather than later, which kind of gives you the overall picture much better. Yeah, so that's the flow chart. And unfortunately, I can't get it all of it at once, but we'll go through it. So in a way, you can think of this gives you only the inner loop logic, not the UF. UF is this whole thing you can think is embedded inside inner loop. So we'll have two variables, sum and count. And has next means that data is not sentinel value. If data is not sentinel value, read BP, think of that reading a score. I improvise this from a blood pressure program. And then sum will be sum plus BP. BP means one score, and you increase the counter. And then you're reading the next value, and you keep going in this loop until next value is sentinel value. So you stay in this loop, keep reading it. When that becomes false, then we go here, we get the average equal to sum divided by count. We use num test earlier, and we find the rounded average, and we print average, sum, and number of tests. Count is number of tests, and then rounded average, and then we assign the grade. And this you have seen before. If rounded average is greater than or equal to 90, if that is true, grade is A. But if that is false, we'll check for 80. If that's true, grade is B. And then we'll check for 70. If that's true, grade is C. If that is false, we'll check that rounded average is greater than 60. If that's true, grade is D. Otherwise, else grade is false. So that's the logic of the inner loop and the grading done after that. Okay, so just think of BP as the score. One day I'll have time to modify this. So now we're going to show you this loop, this if and else, UF loop, and if conditions to open file and file validation. Okay, so let's go for that. Now we are going to use some formula. So let's look at the computational expressions first. So those are not very hard. Some will be some of all test scores for one student read from the file. This will be 0 for student who did not take any test, and it could 0 be even for a student who took one test but got 0, or a student who got 0 in all the tests. So, but it will be non-zero value, higher than 0 value, positive value for a student who got greater than 0 at least in one more test. And how we're summing that up was shown right here, like this. Okay, in algorithm we'll show this again. Right now we are just analyzing. Okay, so a num test is number of tests taken by the students as read from the file, and then the mean will be sum divided by num test. In math you can just write that because math you do on paper, but when we want to find the real average, if I just do sum divided by num test, that will be integer division. That's going to throw away the fractional part, decimal parts. So we're not allowing that to happen. So we cast numerator to double type and then divide by num test, which is int type, and then we get the real average. So this will be not throwing away the decimal parts. But to find the mean, what we do is we add 0.5. Meaning of that is that if this value has the decimal part 0.5 or above up to 0.9, adding 0.5 will means that this will go up by 1 point, but because we are casting to int, but if decimal part here is less than 0.5, then decimal part after adding 0.5 will remain less than 1, and we cast by into int, that will be thrown away. So we are kind of rounding down. We're rounding down by throwing away the decimal part if decimal part of mean is less than 0.5, and we are rounding up by 1 point if decimal part of mean is 0.5 or above. We've done this in many times. I've done this in class, so the principle remains same. Now remember the expression 1 and expression 2 because we're going to be using that in the Boolean analysis table. I'm not going to discuss longer formula because those are for additional computations. You can read them and so on, so I'm not going to worry about those. Read them and figure out themselves. So next is the table of Boolean conditions. Now understand two principles. One is what is or are the highest level selection, because highest level selection will be done first one. Generally in software you don't start loops right away, although that can happen. You do some sort of if and else, some sort of selections first, and then you do what are the algorithmic tasks embedded inside them. So inside those tasks may be more selections and repetitions. So example of that would be, we can show you in different ways. So for example, here I'm doing a loop and there's a nested inside that is another loop. Okay, now you want to see about selections, then I can go to that flowchart I showed before. So imagine this will be inside the UF loop. So here we are doing selection about the grading, whether grade is A, B, C, D, or F. And this whole thing will be sitting inside another selection, whether file opens successfully or not. We have not been able to see everything, show you everything, because the diagram will then become huge. But we are going to explain that to you right now. Okay, so first is that you will have an if stream object that we are calling in. So the way we do is that we keep deciding what is the first level selection, what is second level selection, what is embedded inside that. Are there loops embedded inside that? Are there more if and else embedded in that? So what we do is we keep layering selections and repetitions as needed until we have constructed the structure of the whole software. And this is also shown by a flowchart which I just showed you. The flowchart only has some high level details. So that's my first Boolean condition table. You can do it in this way, the way I've done it, by embedding things, or you can do like one and tell user, okay, go to the table number such and such. We have shown that in design example 3, and we have shown some of that in design example 4. So you have two previous design examples to look at how to do Boolean condition tables, but they should all have all Boolean conditions, left file the same thing. Whatever conditions are missing, the points will be deducted for that. All right. So first selection is we check whether input file is successfully opened and has data in it. And we do that by calling isOpen function. By the way, this is not going to check whether data is there or not. We'll have to do something different for that. So in.isOpen checks whether file is successfully open. And if that's true, we'll use the if structure under that will be all this algorithmic task, okay, up to here. Now if that is true, file open, input file open successfully, then our next algorithm task inside that is open output file. And then we do this table, that after opening output file, we make sure that opens successfully as well, just like this one did. So Boolean condition for that is out.isOpen function. If that function returns true, then output file is successfully opened, and we'll use the if structure for that. And if that is true, then we can execute the inner loop. And the first loop inside that is the EOF loop. So Boolean condition for that is in.peak is not equal to EOF. If that is true, then we will design our EOF while loop. And there are a number of algorithms we can do inside the EOF loop. First one is that we count how many students are in the file. There will be num student equal to num student plus 1. And then we are going to show you more in the table 2 how sentinel loop is done. But basically, if you want to see a picture of what is done all this, then we actually already showed you. So basically, that's pretty much the picture that happens inside the EOF loop. Okay, so picture was there, and here we are just showing you the formal presentation of what is done when this condition is true. We increase number of students by 1, and then in the table 2 we show you what more is done. So look at the layering here. Layering is very important. I'm a stickler for layering. Under this layer I have this whole thing. Under this layer then I have this. So this is one layer, this is other layer, and inside that is this whole layer. Yeah, I mean, it would have been better if I showed layers in different colors. Maybe I can do that in some other example in future. Now, if isOpen does not return a true, it's going to return false. And in that case, I'm going to use an else block, and I'll just say fail to open input file. And same thing happens here. If output file is not successfully open, then isOpen is not going to return true, it's going to return false. That will be an else block, and in that case I'll say fail to open or create output file. Here I've done embedding of layers. You don't have to do embedding. You can do one layer and then ask user to go to the next table, which will be another layer, or third table, that'll be another layer. It's your choice. But I need to know and understand clearly that you have understood the software structure. I would not know that until you do Boolean conditions and their relationship through layers. Okay, that's what I need to know. And if you have not understood, you somehow came up with this source code, that's not good, really, because that means you have not understood the software structure. Understanding software structure is just like, okay, so everybody is talking about viruses these days. A virologist understanding the structure of the virus accurately, like where is the protein layer, where are the coronas, where is the RNA molecule located, and so on. That's how you have to understand each part of the software as well. Outer layer, next layer, third layer, fourth layer. Okay? So that's very important. Without that, you cannot understand software that has been designed or build a software that you are going to design. Okay, going to table means after doing this increment of number of students, we'll see more. So go to table 2. That's table 2 where we do the prime read, and actually prime read is done before, but we're testing this condition in the sentinel loop. And if this value is true, then we have sentinel while loop. And inside the while loop, we continue reading and processing student data until sentinel value of one score is read. After each read, we say sum equal to sum plus one score. We count the number of tests. And we showed that to you earlier, for example. So this will go very well with that picture that we showed you before, that in the loop, once this condition is true, then you'll add this score to the sum, then you'll read this, add to the sum, and increase the number of tests. Each time you're doing a sum, you're increasing the number of tests. Then you, in the second loop iteration, you will read that, add. Third loop iteration, you will read that, add. Each time you are increasing number of tests. Finally, when you read -1, you exit the loop. This is pictorial form, and the one I was showing you in table 2 here, that's the table form. And we need to know both. Okay, we need to know both, have both. In your lab 5, you don't have to do pictorial form, you can just do this one. But if you want to do both, that's fine too. So obviously, as long as this condition is true, I'm in my sentinel loop. When this condition is false, I exit and loop is not entered. Okay, so for some people, this could be the very first thing. In that case, variable num test and sum will remain 0, and this will happen for the student who didn't take any test. But this will evaluate to false at some point where sentinel value is read. Okay, so by the time we have done that much, there are only two possibilities: that number of tests is 0 or not. So grade determination we do based on this Boolean condition. If num test is greater than 0, that means the student has taken at least one or more tests. And if that's true, then we use the if statement, and we use expression 1 to compute mean, see page 6, expression 2 to compute rounded mean, see page 6, and I can show those to you again right here. This is a C++ form. So we'll cast sum to double type, divide by number of tests. This will give me the floating point value, and then rounded this way. Is the rounded value we'll use for finding the grade. So what we do is that if rounded mean is greater than or equal to 90, if that is true, we use if structure. We set the grade to A. Again, these you have to read and understand. If it's greater than or equal to 80, then we use else if, grade is B. If it's greater than or equal to 70, then we use else if, grade is set to C. If it's greater than or equal to 60, we use else if, grade is D. And if it's less than 60, if that is true, that will just an else block. So it will be if, else if, else if, else if. Put these conditions here, 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 these conditions, and else will be set the grade to F. These lines you'll have to read the document and understand. But if num test greater than 0 is false, that means they have not taken any test. And in that case, we print no tests were taken. Okay? So this is it. That's the design analysis. And this is very, very important for, depending upon the complexity, formal part of this can be done in 2 or 3 different ways. So the way I've shown you Boolean tables, this is always done. Okay, if you're not going to do anything else, you at least have to do this much. But if you want to do the logic diagrams like these, this, and this for some complicated part of it, you can do that too. Or you can do the flowchart, which will revisit again in the algorithm part of design example, which will be the third video. So That's pretty much what I wanted to tell you and show you. Uh, this is how you decide what are the highest level selections. You set those up like this is in opening input file for me is the highest level selection. If that's true, then what am I going to do after that? Then I'll ask this question: what are the algorithmic tasks embedded inside it? And those tasks may be more selections and repetition. So obviously, if input file is opened successfully, then I'll do the code for opening the output file, where I will get the output file name, do out is open, out will be off stream type. If that's true, then obviously I can execute the outer loop where I'll ask if in.peak is not equal to UF is true. If that is there, then I'll do the UF while loop. In that, there's one simple statement to find number of students, and then I'll do a whole bunch of algorithm which is described in table 2. So I'll describe this one more time. So I'll do a prime read. If prime read is greater than or equal to 0 is true, that means the student has taken one or more tests. So I'll get into sentinel while loop where I will read, update the sum and the number of tests, and keep reading until this condition becomes false, which will be when sentinel value is read for one of the records. But if this is ultimately it'll be false and it will never be entered for person who took no test, and then we'll exit the loop when this condition becomes false. Then we assign grade based on the fact that if students has taken one or more tests, the num test is greater than 0. And these are the grade thresholds, and those are the grades based on that. So that's pretty much table of Boolean conditions analysis, arithmetical expressions for this design example 5. So I'm saying Dr. Singhal, Professor Computer Science at Community College, saying goodbye to you from video number 2 of 4. Our 3 will be on algorithm. Foundation of our algorithm will be all this analysis. Video 1 where we chose the names, because we don't change names once we choose them. And the last one will be just coding that algorithm into source code. By then actually we have done so much work that everything is pretty much crystal clear. So thank you for watching, and I'll see you in the next video.